All right, good afternoon. This is the final help session for your final exam. Your exam is on Monday. It'll be on Respondus, and I have it from 12:30 to 3:30, so that's the window. Um, and it is going to be, you'll have 2.5 hours, or what's that, 150 minutes. Please try to start closer to this time because we've been having some issues with Moodle just being too slow or even locking up. So please try to start early. It'll help if you're starting before everybody else starts at 1 o'clock. So please try to start at 12:30. You'll still have the same amount of time. If you can't start at 12:30, then just wait until, I don't know, 1:30. If you encounter a problem, I'll send this to you in an email, but if you encounter a problem, please call me at this number during the exam. Don't email me, call me. Don't text me, call me, like with the voice, and then I'll talk you through it. And just relax if you have issues, but call me. I can deal with it on my end. Okay. So for this help session, you don't need to take notes and submit them to me. Actually, I only had a few questions, but I just want to sort of prepare you for what to expect. So no need to take notes. I'll give everybody the 3 points. There are 48 questions on the exam. The answers and the questions, unfortunately, are scrambled. I know the questions are scrambled, so they come out of order, and then the answers might also be scrambled. So for example, you might have something like this, where you have A, B, C, D, and then you have D, C, B, A, or whatever. So you have the options scrambled, and so if you pick the answer to be B, then it would be this option. So just be aware of that. I'm not sure if that's true, but they might be. I know for a fact that the questions are scrambled, and I tried to fix it, but I just couldn't fix it. I'm not sure what it was. The exam comes completely from your old exam. So if you want to prepare, that's what you do. You look at these exams, the spring 2020 exams 1 through 4. For exams 1 and 2, you had free response. There is no free response. There aren't even multiple choice that are like the free response. Okay, so as you prepare for the exam, just don't practice the free response. There's no need for that. Okay, so there's no free response. Okay, so some of your questions, I have 3 questions, asked me to go over the rules for capacitors and resistors. Of course, there will be a lot of capacitor and resistor circuits. There were a lot on the exams, and you do the math. There's 48 questions. That means I'm pulling on average 12 questions per test. So that's a lot. That in some cases that's more than half. So I would expect to see a lot of circuit problems. And so for capacitors and resistors, we have very similar rules. So first of all, for capacitors, let's break this up into series and parallel. Series and parallel. So for capacitors in series, the equivalent is equal to 1 over C plus 1 over C. For parallel, the equivalent is equal to C1 plus C2. For resistors in series, the equivalent resistance is equal to R1 plus R2 plus however many resistors I have. And then the equivalent for parallel is 1 over R1 plus 1 over R2. Okay, so note here that for resistors, the rules are switched from what they are for capacitors between series and parallel. Okay, what was the next one? Capacitors in series, the voltage on an equivalent capacitor is equal to the individual voltage on the individual capacitor. So for example, if I have this capacitor, if this is 12 volts, these two capacitors, voltages here and here, have to add up to equal to 12. That's true, by the way, for resistors too. The same exact rule holds true, that V is equal to V1 plus V2 plus however many capacitors I have. So let me pause this for just a second. Okay, so for capacitors in parallel, this isn't really a rule that we use very much, but it's still true that Q on the equivalent capacitor is equal to the sum of Q1 plus Q2. But again, not a rule that we really use, just not a really useful rule. However, for resistors in parallel, over here, the I total equals I1 plus I2. And that is useful. That's Kirchhoff's rule, right? That the current in is equal to the current going out. Let's see, 3. I might be doing these out of order from the way I showed you in class. So for 3, all capacitors have the same voltage. Not same voltage, same charge. For capacitors in series, for capacitors in parallel, they have the same voltage. For resistors in series, they have the same current. And then for resistors in parallel, they have the same voltage. And then finally, the fourth rule is just Q equals CV. Q equals CV. This is for an individual capacitor, or V equals IR. V equals IR, Ohm's law. That's for an individual resistor in the circuit. Okay, those rules are really important, and you'll see those circuits, gosh, 7-8 times probably on the exam. You can look back at the screencast. I have a bunch of problems I do, but then also, primarily focus on those 4 exams. And if you have difficulty in one of those exams, you can go back and brush up from your notes on how to do those particular questions or problems. I have a couple specific questions from those exams. And then if you have additional questions from them, by all means, please ask me. You can even ask over the weekend if you'd like. Let's see, the question. From exam 3, this number 16. This is the one with the magnet and the loop of wire. So this is like an electric motor. Think of an electric motor. It has a magnet, and then there's a loop of wire that sits in the middle of it. And when you run a current through that wire, it causes motion because you have a current and a magnetic field. So here the current is going in the direction that the arrow. So I have a current going in that direction and a current going there. So it's, if I'm looking down, it's going clockwise. And then the magnetic field here is going in this direction. Okay, so I'm just going to look at this side. I can look at either side, but I'm just going to look at that side. And in that side, I have a magnetic field that's in that direction. And I have a current that is going into the page. And so if I take my index finger and point it into the page, and then my middle finger goes in the direction of the magnetic field, try that right now. Index finger in the direction of the current, that's pointing down towards the page, and then the magnetic field is to the right. So my thumb then is going to be pointing downward. So this is the force. So I have a force on this side that's down, and on the other side I've just switched the direction of the current. So that means I'm just going to switch the direction of the force. So if you imagine I have this loop of wire, well, imagine that it's a steering wheel. I have one force pushing up on that side and another force pushing down on that side. That's going to cause this thing to move in a counterclockwise direction. Okay? Probably going to see a question like that. There's a lot of right-hand rules, so make sure that you've reviewed your right-hand rule. Every application that we did is on those exams for exam 3. There was another question about the light bulbs. I think that was exam 2. Yeah, so these light bulb questions. We'll look at both of these. Let's do the first one first. Consider these 3 circuits. Which provides the most light? So in these, when you have light bulbs, we had a power equation, which is V times I. And each of these light bulbs will have a different voltage. However, they also have a different current. So this is a difficult equation to work with. A better equation to work with when I'm dealing with devices that have the same resistance is this equation, the V squared over R. Because it's fairly easy for me to figure out how their voltages differ, and I know they all have the same resistance, but it's more complicated to figure out, okay, what their voltage is doing this and their current's doing this. So just working with this equation and these types of problems is a lot easier. So I'm going to label the voltage. So if I imagine that this light bulb has voltage V, that means these 2 light bulbs have voltage divided by 2. So if this has 4 volts, then each of these has 2 volts, for example. In this circuit over here, these 2 light bulbs are in parallel, so they'll both have V. So I'm assuming that the battery provides a voltage V, and then each of these light bulbs will have these voltages, V over 2, V over 2, V, V, and V. So because I have half the voltage on these 2 light bulbs on the far left, the power that they get is going to be 1/4 the power of this light bulb. Because I have that factor of a half in the voltage, and since the voltage is squared, it turns into 1/4. So if I just look at the 2 light bulbs on the left, I'm going to get 1/4 the power and 1/4 the power. I'm going to get a total of 1/2 the power as what I get on just a single light bulb. Now, that doesn't really matter because I'm looking for the one that provides the most light. This one is going to provide twice the light of B. So C is going to be the right answer there. Okay. But it all depends on how the voltages are distributed, or what are the relative voltages. And if I have, even though I have twice the number of light bulbs, each of them has half the voltage. And having half the voltage because of this quadratic relationship gives me 1/4 of the power. And anytime I talk about power, I'm also talking about brightness. The power and brightness are related to one another. And number 13 is really similar too. In fact, if you got number 12, you probably get number 13. Which of these statements is correct? Okay, bulb A is twice as bright as bulb B. Okay, so if I imagine that both of these batteries have a voltage V, this one gets V over 2, and this one gets V over 2, and this one gets V. So bulb A is actually going to be the same as bulb B. And bulb A is 1/4 as bright as bulb C. Okay, yes, because it has half the voltage. P equals V squared over R. If I have that voltage, then I'm quartering the power. So this bulb, because it has half the voltage, has 1/4 the power as bulb C. Bulb A is 4 times brighter than bulb C? No, that would be true if it had twice the voltage, but it doesn't. It only has half the voltage, so that's not right. Bulb A is 1/2 as bright as bulb C. No, it's not. It's 1/4. And then bulb A is twice as bright as bulb C. So no, that's not the right answer either. Okay? So you definitely have questions like that. I think those are all the questions that I had from students. If you have other questions, then please let me know. But let me go back to if you have other questions, let me know. But I just want to go over the details again, that you will be using Respondus Monitor, and so you'll need a webcam. If your internet is spotty, you might want to try to go to a friend's house or something where they have more reliable internet, or maybe even on campus. Yeah, I guess you could go sit outside a building. But really the big issue that we're going to face is Moodle. So if you have issues with Moodle, just give me a call, a telephone call with voices, so I can hear your voice and we can talk it through. And call me right away. Okay. I do just want to say that I'll be stepping up. That the final is an important exam. I'll be stepping up the just my viewing of what your sort of your integrity. So those videos, I do look at those. In fact, I get a like a digest of them, and I go and I review them. So make sure that you're appearing to be honest. Not just that you're being honest, that's really what I want you to do in your heart, to be honest, but that you have all the appearances too, so that I have no reason to think that you're using outside resources. Make sure your environment check is thorough, and make sure that you're in a quiet place with no other individuals or other devices. Okay, that's all. Remember, you don't need to submit your notes for this. I'm going to grant the 3 points extra credit to everybody.